Good day, viewers. I am creating these videos to support teachers of maths in helping learners make sense of mathematical concepts and their associated procedures and processes. And today I thought I'd have a look at substitution. Now, if you've had a look at my introduction to formulae video, then you'll know that I quite like using Cuisenaire rods for introduction to formulae. I'm not quite so keen on using them for substitution. I think they're really nice for being able to see formulae in different ways and being able to write down formulae. But when talking about substitution, unless you pick your values very carefully, then you get the relationships, particularly the multiplicative relationships between the different rods, gets destroyed. You might end up in a situation where the red is not double the white, or the blue is not 3 times bigger than the green, and that sort of thing. And I don't like that you have to choose your numbers so carefully for that. So for me, I like using algebra tiles to support making sense of substitution. And again, this is one of those situations where actually, in terms of as a modeling tool, I feel that the virtual manipulative actually has some advantages over the physical manipulative. And although I would be using the physical manipulative with pupils in my class, I would probably start from the virtual manipulative and talking about it through that. So let's have a look at, say, an expression to start with. Let's have a look at a relatively straightforward expression. 2x plus 3y. And so I'm going to build that expression. Here we go. 2x plus 3y. And then let's say I'm going to substitute values for that. I'm going to substitute the value that x equals 5 and y equals, let's go with 3.5, because why not? Okay, so x equals 5, y equals 3.5, and so all I can, and this is the power of the virtual manipulative here, all I need to do is change my variable label from x to 5, and my y variable label from y to 3.5. And we can see what's happened there, can't we? We can see what's happened, that this length has now become a length of 5. This has become a length of 5, 3.5, 3.5, and 3.5. And of course, the idea there is, okay, well, can we work out how long that would be? 5, 10, there's another 7, so 17. 20.5, and that's all it becomes. It becomes those lengths which were always there to model and to represent the value, whether it's a variable value like an x or a y, or whether it's a fixed value like a 5 or a 3.5. That's what that was there to do. That length, that area, was supposed to represent that value, and so all it's doing is taking on that role. That total length was 2x plus 3y, and it's now 2 5s plus 3 3.5s. And of course, I could bring in negatives as well. So I could say, well, what happens if it's not 2x plus 3y? What happens if it's 2x minus 3y? Well, then, of course, instead of having these, I would just have these. Now, potentially, you've got to be a little bit careful with products here, and particularly products of two variables, as I'm sure you'll have noticed. If I change those back to x and y for the minute, x and y, if I change those back to x and y for the minute and just tidy those away, you can see that this is the product of an x and a y. But if I now change, so if I was looking at the expression x, y, then this might be the product of that I would build. But if I now put in x as 5 and y as 3.5, then you can see there's a potential problem there. And there's a potential problem where you've got 53.5 and it looks like 53.5, but it's actually supposed to be 5 times 3.5. So I would steer clear of expressions like that when using something like this. I would either do it just with the virtual to the point where pupils are understanding the numbers substitution, so I don't actually need to change the variable labels, or I would leave it purely until pupils are happy working in the abstract. However, one nice formula, if I just put these back for a minute, I'm going to change them to L and W. One nice one here is a sort of a linear formula that I could bring in. And the formula is P equals 2L plus 2W. And so I can build this 2L plus, not that one, 2W. There we are. I've got my 2L plus 2W. And again, I can change that. So I can say, what if L was 7 and W was 4? And you'll have noticed here that I am, in both cases, making the value of my Y smaller than the value of my X, or in this case, the value of my W smaller than the value of my L. Now, that's not absolutely necessary, but certainly in the early stages, if I've got a smaller rod that's longer, or a smaller tile that's supposed to have a larger value than the longer tile, that can get a bit confusing. So I would just, if I have these numbers in mind, while we're in the early stages, while we're working in the concrete, I would actually do that. So anyway, I can change this L to a 7, and I can change this W to a 4. And now I can evaluate that as an expression, 2 7s, 2 4s, or I could potentially show the equivalence to 7 plus 4 twice. But the other thing that's really nice that I can, of course, do with this is to actually show that as the perimeter of a rectangle, which of course is where that formula comes from. And that's a very nice linear formula that I always like to bring in, because with the tiles, we can actually show how we are recreating that to get a value for that perimeter, and that creates that nice link with perimeter as well, and perimeter of a rectangle in particular. So that is my short video on how I might introduce the idea of substitution using, in this case, algebra tiles. As always, I'd like to say a big thank you to mathspot.com and its creator, Jonathan Hall, for this fantastic website, which not only houses all of these virtual manipulatives that I am using to bring these videos to you, but also a wealth of other great material. And if you haven't yet been to mathspot.com and had a look through it and got familiar with all of the wonderful things it could do for your teaching, then please do. It's well worth a good look, and it will make your life as a teacher easier. And again, if you are interested in using manipulatives and visuals to support your learners with making sense of maths concepts, then I would suggest you check out my website. My website is visiblemeths.co.uk, and one of the things you'll find in there is you'll find a section called Visible Maths Book, and that's because I did produce a book called Visible Maths, and the book came before the website. That's why the website is called Visible Maths. But in that section of the website, you'll find a link to the book. You'll find a link to the publisher in particular, who is Crown House Publishing. And on their website, you'll be able to view some sample pages. And if you feel like it would be a useful addition to your teaching and learning library, then you can, of course, place an order. I will be making these videos throughout lockdown and potentially beyond. So if you want to see a particular concept or process or procedure modeled using manipulatives or visuals, then please do get in touch, and hopefully I'll get around to creating it for you. Thank you very much for your kind attention today.